Okay, so chapter 14 bingo. The first problem is number 52, and it says that we have a sphere of mass m is attached to a massless rod of length L that is pivoted at the top, forming a simple pendulum. The rod is pulled to degree theta and then released. This is a multi-part problem. It wants us to draw a couple different diagrams describing what's going on. The first one, it asks us to draw a diagram to show the acceleration just after the pendulum's released. So we just draw our little vertical line here. We know that the rod that the pendulum's attached to has a length L and it's pivoted to angle theta. Our sphere has a mass of m. And then we can just draw a little free body diagram right here, illustrating the pendulum right here. We know that the thing bringing it down is its weight, so that's going to be mass times gravity. We can draw kind of a little line there, kind of showing the motion of the pendulum there. Let me get on this side here, and then we can see it moving tangent to any point along that motion is going to be its weight, mass times gravity, times sine theta. And then the line exactly perpendicular to that is going to be mass times gravity times the cosine of theta. And we have the sine and cosine there. The reason for the sine is that that's going to be moving up and down the motion of the pendulum, and then the cosine is just because that's going to be perpendicular to the sine. And then we're asked for the acceleration of the pendulum just after it's released, and that's simply going to be the gravity times sine of theta. And then the second part, I didn't write it down. Okay, so it says to repeat part A for the instant when the pendulum is at half of theta. So for that one, we pretty much draw the same diagram, all except for this whole thing right here is going to be the original angle theta, and where the pendulum actually is theta halves. And then everything else just goes off of the theta half. So the velocity there is going to be mass times gravity times sine of theta halves. Mass times gravity times cosine of theta halves is going to be the tension on the pendulum. And then the third part, part C, says to repeat for when the pendulum is at the vertical line. So then our diagram's just going to be that right there. And then this is really nice because then once again, the thing pulling it down is going to be its weight. And at this point, when it's exactly lined up with the vertical, your acceleration is going to match up with your tension. So the pendulum, in effect, is going to have a vector going directly upwards to bring it back up into the swing and back down.